All right, number 1, x squared minus 10x plus 17. The direction said to put it in standard form, or to change from standard form to vertex form by completing the square. So the first thing we're going to do is our first step up here, which is putting the x's together and adding some blanks. So when we look at this thing, I'm going to get x squared minus 10x plus a blank plus 17 minus a blank. That's our first step. Organization. Putting our x's together with a blank and my y's together with a minus blank. Okay? Step 2 is filling in our blanks with half of b squared. So which number up here, Dorian, am I cutting in half and squaring? Negative 10. He's going to take this number right here. He's cutting it in half, and then he's going to square it and put it right there. So what's half of negative 10? Negative 5, and then I'm squaring negative 5. 25. So he's putting 25 in this blank, and then this blank will be a minus 25. That was step 2. Step 3 is putting it in vertex form. So know what vertex form looks like? It's x squared, just like that. He's going to have a number inside the parentheses and then some number outside the parentheses. To get the number inside the parentheses to go with the x, remember all we have to do is cut our b in half. So Zaru, what number is going to go with my x here? Just cutting this in half. So what's half of negative 10? Just negative 5. Yep, negative 5 goes there. Out here, we're just putting these two things together, and that will give me that number. So negative 17 minus 25. Yeah, positive 17, negative 8. Sorry, I said it wrong. Good. We get to that point right there. That is vertex form. X minus 2. I'm going to rewrite it here so I can graph it. X minus 5 squared minus 8. Now my job is to find the vertex and then graph it. So if I'm finding the vertex there, Juanito, what do you think my vertex is going to be? 5 is my x value. Good. And my y value? Negative 8. Changed the sign, kept it the same. 5, negative 8. Great. Once we've done that, we can graph that. So we're going to 5, negative 8 up here. 5, negative 8. That's our starting point. It's a parabola. My normal parabola pattern is 1, 3, 5. Looking at this equation, did my pattern change at all here? Is there any value in front here of my parentheses? Nope. So it's a 1. That means my pattern didn't change. That means from here I'm going up 1 over 1, up 3 over 1, and up 5. 1, 2, 3, 4, 5 over 1. There's my parabola. Questions on the first one? A reminder that if you know how to use your calculator correctly, you can always double check your picture and make sure that it matches. I think that would be a good use of your time to double check yourself. Let's look at number 2. So number 2 is a little bit harder. 3x squared plus 12x plus 2. We are again finishing it by completing the square. But remember with this one, since I have the 3 in front, I got to do some work first. Genesis, since there's a 3 in front of that x squared, what do I have to do with it? Yep, I got to divide that by 3. And what else do I got to divide by 3? Yeah, I think, yes. Divide both of those things by 3. She's taking a 3 out in front. She's factoring out in front. And so that's going to leave her with x squared. 12 divided by 3 would be plus 4x plus blank. And then out here she's going to have plus 2 and a minus blank. That's step 1. Step 2 is filling in our blanks with half of b squared. So Bridget, what number am I cutting in half and squaring? 4. What's half of 4 going to be? Half of 4 is 2, and then 2 squared. 4, yep. So she's putting 4 right there, but she's not going to put 4 in the other blank. What do we need to do to fill in the other number in the blank? Multiply by whatever number we took outside. We took this 3 out in front. Since it's in front, it's like we have to distribute it. 3 times 4 gets us a 12 out there, a minus 12 in that blank. That was step 2. We filled in our blanks with half of b squared. Step 3 is putting it in vertex form. So in the end, it's going to look like this. Muhammad, what number is going to go with my x in there? 2. What'd you do? Yep, he took this number right here and cut it in half, so half of 4 gets him plus 2. And minus 10 out here. 2 minus 12 is minus 10. There's my parabola. Or at least my parabola in standard form. If I want to graph that, now I need to find my vertex. Tadiwa, what do you think my vertex is going to be? What do we want to do with that 2? Yep, change that sign there. -2, good, and -10. That's my vertex. -2, -10. So up here I'm going to -2, -10. My normal pattern is 1, 3, 5. But Diana, you're saying my pattern changes? What's my normal pattern is 1, 3, 5. What do I need to do with that pattern? Yep, since I have this 3 out in front, she is multiplying her pattern of 1, 3, 5. She's taking everything and multiplying it by 3. So her new pattern is going to be 3, 9, 15 when we graph that thing. So down here, starting at that first point she had, she's doing 3, 9, 15. So she's going up 3, 1, 2, 3 over 1. Up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And then 15 would go off my paper, so that's enough. Give us something like that, and it's obviously going to keep going. Questions with 2? Bless you. Number 3 says find the vertex using -b over 2a and then graph it. Okay, we're finding the vertex using -b over 2a. So to find my x value, it's telling me I got to use that. We can identify our A, B, and C first. Alexis, what do you think my A value is going to be here? -2, good. My B value? 28. And my C? Wonderful. That's her A, B, and C. So to find her x value, she's using -b all over 2 times A. So it's -b, so it's -28 times 2 over -2. When I multiply this together, in the end, is my answer going to be positive or negative? Positive. We got a negative on top and a negative on bottom, so I know it's going to be positive. I always multiply across the top and across the bottom first, so it's 28 on top and it's 4 on bottom. 28 divided by 4? 7. That's my x value. Once we find our x value, we did -b over 2a to find our x value. What are we going to do once we find it? Plug it back in. So we're taking that number and we are plugging it in for x. It's just a matter of being good with your calculator. It's not always super easy math. You just got to plug it in, though. Let's see what we get here. So make sure you plug it in parentheses, -2. Yep, clear. Oh no, my calculator's not working. There he goes. Man, it doesn't like me today. Whatever. Somebody get me an answer. It's not loving me. 9? Somebody agree with 9? All right, sounds good. Sorry about that. My y is 9 when I plug back in. I guess I could have actually done the math, but that would have been too much work. So 9 is that. My x is 7. My y is 9. My pattern is normally 1, 3, 5, but we had this -2 in front. So I'm going to multiply everything by -2, so my new pattern is really going to be -2, -6, and -10. Let's graph it. 7, 9 is going to be my starting spot. -2 over 1, -6 over 1, -10 over 1. There we go. 3 parabolas graphed. Questions on something we did with any of those 3? So these next 3 are a little bit just next step to it. Nothing crazy. The first one's easy. Again, a lot of the times we look at a problem like this and we'll get frustrated because it looks different. Don't let the little bit looking different bother us here. It says the graph shows a path of a ball thrown into the air from the top of a building. The x-axis represents time in seconds and the y represents the height in meters. Use the graph to answer the question. So what is the height of the ball 3 seconds after it is thrown? So if we're looking for 3 seconds, time in seconds, we're going to 3. What did we get for that one there? Carly, what did you get for number 1? Yep, 10 meters. Good. She's good looking right here. That's where it's hitting at 10 meters. Number 2 says, what is the maximum height of the ball? Sergio, what did you say for that one? 18 meters. Good. He's looking at the highest place right here, and the question was what? If you remember, when we get a question like what, normally what refers to the y value, and that's what it's doing here. The what value means what is the height. The height is your y, and so he said the height was 18 meters. So Sergio, when does the ball reach the maximum height? 1 second. When is a time thing. Since the x-axis is your time, that means it's right here. His x is 1 second. How long after it's thrown does the ball hit the ground? What do we think there, Jose? At 4 seconds. Yep, that's when that ball reaches 0. That's when it's hitting the ground. It looks like it goes down. Do you think that ball really goes underground? No, it's a parabola. It's just like this over here. This is negative time over here. Negative time doesn't exist either. It's just what you have to do in math. You have a little bit of stuff that, oh, not 0, 4 seconds. You just got to be smart here. So the other thing you could do with this that we do quite a bit in pre-calculus and things like that is how high is the building? So there's the question there. Look at that story problem again and figure out how tall were you when you threw that ball off the building. Anybody got an idea on how high the building is? When would the ball have been on the very top of the building? At what time? Right when I threw it, because I was throwing it up. So what time would that have been? At 0 seconds, right? Right before I threw it, that ball was hanging out right at the top of the building. And then as soon as I let go of it, then it started to go. So if I want to know how tall the building was, it would be at 0 seconds here. At 0 seconds, it looks like about 16. Does that make sense where I'm getting that from? A little bit different. Write the equation of the parabola in vertex form. So vertex form, some of us struggle with that idea. This is vertex form. Just like this. There are 3 things you need to put this in vertex form. I need my x value, I need my y value, and I need to know what my pattern is. Those 3 things. If I know those 3 things, then I can figure out what the pattern is here, or what my story problem, or what my parabola is going to look like. So the first thing we're going to do is find the vertex. As you look at this one at Zelli, where do you think our vertex is here? So I went this way, I went over 3, and then I went up 2. My vertex is 3, 2. Next thing I'm going to do is look at my pattern. Okay, so as I look at my pattern here, I started right here. What did I have to do from that first dot to get to my next dot? How many did I have to go down to get to my next dot? Down 2. Then how many did I have to go down? 6. So it's -2, -6, and then you can't see it, but what do you think the next one's down? -10. That's the 2 things we're going to use right over here. Okay, once we know that, we can use that to plug in here. So Diana, what do you think is going to go with my x then? With my x right here? What do we always do with that thing with our x? -3, because we're going to change the sign. So a -3 is going to go there. When it's with our x, when it's inside the parentheses, we change the sign. On the end there, Diana, what's going to go out there? +2, because out there we keep it the same. And then in front, we need to put our a value. Remember, the a value is the number we multiply our pattern by. Normally it's 135, but here our pattern is -2, -6, -10. So what did we do to go from 135 to -2, -6, -10? We multiplied our pattern by -2. That is the parabola. That's the equation of my parabola. Questions on number 2, a little bit tougher. Made you think a little bit, maybe. Number 3 says a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket can be modeled by that pattern. When will the rocket reach its maximum height? Well, anytime I'm talking about maximum height, this is a parabola. I know it's a parabola because it's squared. It's negative, so I know the parabola is going downward. Okay, so if I want to know the maximum, I'm finding the vertex. So the easiest way to find that vertex, Muhammad, would be what? It is in standard form. So I'm going to use x equals, negative b over 2a. Negative b over 2a. So if I'm setting this thing up, what is my negative b here, Muhammad? 64. So it's negative 64. That's this number right here. Over 2 times my a, so 2 times negative 16. You have 2 negatives. So when is the time going to be? Is my time going to be a positive time or a negative time? Positive. It wouldn't make sense to have negative time if you use your brain and think about it a little bit. It might help you out. 64 divided by 32 tells me my x value is 2. So when will the rocket reach its maximum height? X in this case is our t. That's our time. So 2 seconds is when that rocket will reach its maximum height. And what will the rocket's maximum height be? Christy, what am I going to do to find the maximum height now? Plug it back in. So this negative 16, my goodness, there's being a weird spot right there. Negative 16 squared plus 64, boom, plus 80. Everywhere we had an x up in the equation, or a t in this case, we're going to plug in 2. We're going to type that into our calculator. I'm getting a whole bunch of issues today. There we go. Plug that into my calculator and see what we get. So negative 16, parentheses 2, parentheses squared, plus 64, parentheses 2, plus 80. Type it in, hit enter. 144 is my answer. What is that? Is that meters or feet? 144 feet is how high my rocket gets off the ground. Questions on that one? Sergio? Did I divide 64 by negative 16? Yeah. 64, it's 64, negative 64, because it's negative b, divided by 2a, so 2 times negative 16. So 2 negatives make it a positive. 2 times 16 is 32. 64 divided by 32 is 2.